Hello, and welcome to another video discussing our favorite cybersecurity tools. Today we will be discussing Nmap in greater detail and some of the basic scans to get started using Nmap. So for today, what we have is a Windows 11 virtual machine, this is where we're going to be conducting our scans using Nmap. And our system that we're going to be targeting is a Metasploitable server virtual machine instance here. And what Metasploitable is, it's a Linux server that's has a bunch of exposed um, networked services that's designed to be vulnerable. So this is designed to be played with, to be probed, scanned, attempted to be hacked into, that type of thing. And as we see here, right here, it says warning, never expose this VM to an untrusted network. And what that means is just don't have it, like, you never want to put it on the internet because someone's going to take a shot at it and get into it really easily. The best practice for that is to have that running on just a isolated virtual machine network. And we could set that up in the virtual machine settings here. So you'd go to the machine settings, and under here we can go to network, and you'd want to make sure that you have this connected to a host only adapter. And what that is doing, it is isolating this machine to where only your computer and other virtual machines can talk to it. So, like, say, you have your router in your physical network where your phones connect to your laptop, whatever. Other computers on that physical network cannot access this machine. Only other virtual machines. So that is your best case there. Never connect this to an actual network unless you're just asking for trouble. All right, so that's Metasploitable, and really Metasploitable is designed, for testing these pen testing tools, specifically Metasploit. That's where it gets its name, and that's something we'll discuss greater in a later video. Today we'll just be going over Nmap, network reconnaissance, how to identify that machine, and what applications or network services are running on that machine. All right, so from your Windows machine, if you followed my how to install Nmap video, we're going to be working in the command line, so we want to open up a CMD. Uh, and first thing we want to do is we will run Nmap, and we can get an Nmap listing of all our flags and commands and all our good stuff that we can do with Nmap. Now, for your first scan, best thing to do is to identify how many machines and what types or how many machines are running on your network, and we can accomplish that using a ping scan. And a ping scan doesn't actually try to identify the ports. All it does is it says, like, hey, we got this machine at this IP address that's active. We can see it. We can ping it. And then from there, we can tune our scans and create a list of specific machines that we want to scan. Instead of having, Nmap just testing IP addresses that are not existent on the network. And this helps with scan speed and just fine tuning your scans. So first thing before we can even do that, we need to get some IP information. So in Windows we do ipconfig, and this will give us our Windows IP address as well as our subnet mask, which both of these are important. So the first three octets here of an IP address, that's our subnet information, right? So this tells us that we're on a 192.168.56 network. And down here, this is telling us that it is a /24 in CIDR notation. So what that would look like if we were to do a ping scan is we do 192.168, the target IP address. Oh, let me put in the subnet mask here. 60/24. Okay, so /24, where that number is coming from. So each of these octets is comprised of 8 bits. So what this is saying is that we have 24 bits enabled in our subnet mask. So because 2255 in binary is 8 bits, and 8 bits in decimal is 255. And if we do, 8 plus 8 plus 8, we get 24. So that's where that 24 is coming from. That's CIDR notation. So if we run that scan, we can see we got a list of hosts that are up. And in this case, we're going to want to look at our this one right here, this 192, 168, 56, 111, because it's running on a VirtualBox virtual NIC. So we know that that's our Metasploitable 2. And we know that this is ours, right? The 107, because ARIP is 107. So that is a ping sweep. So once we have that identified, we can take that and we can start, probing and targeting that IP address. And with Nmap, if you're there's many scans. There's scans for that help with stealth scanning, where you might want, if you're doing an actual engagement or a pen test, you kind of want to simulate, what real world attackers do, sophisticated attacks, to where you want to evade security appliances. Now, if we were just to do like a regular Nmap scan, it might get through without anyone noticing, but there's ways that we can tune it to make it less conspicuous. And really, the big flags that we want to look at is the timing scan, which sets the scan speed, and we also want to look at the types of scan techniques we have. So if we were to do Nmap minus T5, and then the IP address, this is going to be the quickest scan, and essentially all the ports are going to get scanned, very rapidly, very quickly. And, if a system has like if there's an IDPS or a proxy or something that's trying to, that your traffic is getting funneled through, and it's trying to identify like port scanning or these types of common attacks that people use to, perform reconnaissance, chances are it's going to get flagged. Now, if we were to set this to like 1 or 2, you'd have better luck, because it would just look like regular network noise. This will just go in very slow intervals while other people are using the network accessing that system. So it's less likely for something to be like, hey, that looks suspicious. And what I'll do is I'll open this up in Nmap or Wireshark real quick, just to show you the differences of these scans, like how much quicker they run. So we'll do -T1, and just for simplicity, I'll just supply some ports instead of doing a bunch. We'll do some of the more common ones here. 9, right? If we run Nmap, we will begin to see some TCP traffic. I just filtered TCP. You can type TCP in the filter bar here, and it'll filter just TCP traffic. And it could take a few seconds to begin scanning, but once it does, you'll get a good idea of the speed. There we are. So first we got it hit port 80, so we could see, on my computer, the originating went from outgoing port to port 80 on the destination here. And it just did one port, and now it did another port, and then it's gonna eventually do another one. And you can see how it's pretty slow. This could take, this would probably take about a minute to finish, just for force ports. Now, if you're doing a system with a bunch of ports, it could take 30 minutes. Now, if we were to stop that and do -5, it already finished much faster, right? So this is really tuning. If you're just doing this testing around, go ahead, do -5. But if you're doing this, if you're planning to be a pen tester, or you want to, or a vulnerability assessment type of person, you're testing firewalls and seeing what it detects, you're going to want to tune these and play around with the timing and try to make them a bit more stealthy. So that is dash T5, and some other flags that we can use to help even further with our scan speed and either making it quicker, slower, whatever, is we have these scan techniques up here. And we have the main one we're going to be looking at today is the dash SS and the dash ST. And what SS is, that's a SYN scan. And what's SYN what a SYN scan is, with um with TCP based connections, you can see in here these little flags here, SYN ACK, right? ACK. And these have to do with the TCP handshake. And when there's a connection, like say if you connect to a web server and it's using TCP, there's a three-way handshake that happens. There's a SYN ACK, and an ACK. And really what this is doing, if you do the a SYN scan, it's just doing a SYN. It's not sending an ACK back. It's just doing a SYN and sees if the server sends back a SYN ACK, and that's it. And that helps, it's not a full, complete scan. And on legacy systems, like older firewalls, some of the older systems may not flag that as a full connection. It might not even record it. In today's world, that's not necessarily the case, unless you're working on some really old stuff. But generally, modern day systems can detect those types of scans, as they'll do a deep packet inspection. Now, where would this be practical for, something like what we're doing? Well, it could help with, speeding up your scans, because you don't have to wait for a full TCP handshake. It just does a SYN. The server says, hey, yep, I saw that, and it's like, okay, that port's open. So that's where your SS is coming in. And then the ST is the default scan. That's a full TCP scan. That's going to wait for the SYN, the SYN-ACK, and the ACK. That's going to do a full connection. And yeah, so that's kind of, these are the two main ones we're going to talk about today. So what this would look like in Wireshark, if we did an SS scan, and we did it on, we'll do port 22, right? Just a single port. We'll keep the time in default. We'll restart our Nmap or our Wireshark capture here. And if we look here, we don't have we just have a SYN and a SYN-ACK. Now, if we did the dash T, we see that we have SYN, SYN-ACK, and an ACK, and a reset. Well, yeah. So it completed the connection, and then it closed the connection, right? Here, it didn't fully create the connection. So we can see that here. Okay, so that is the difference between those ones. And one more thing before we start getting into aggressive scanning is one thing that's very important in pen testing is keeping a record of everything you do. You want to keep a record of your scans, the commands you run, the tools that you use, so that it's easily recreatable and it's accounted for. So how would we say if we want to save the Nmap output? There's a flag for that. We can do -on, and this is to save to in a text format. We do scan.txt, and then we can provide our, our IP address that we want to target. And let's say we just want to do it on port 22. And for simplicity, I'll save it to the desktop so we can see it populate on the desktop here. And we did a scan of SSH, and we have our little scan file here that we can open up, and it saved it. And if you're working with you're doing multiple systems on one big subnet or whatever, it's really good to have these files, and you could just easily save them and parse them later. So if you close your command line or you have a bunch of stuff in here and you're working in the command line, you can always go back and find your scan information. So that is the -on. It's very important. Okay, now this is where we're going to start talking about service enumeration. Now, Nmap has two main flags that we're going to look at. We're going to look at the SV command and the A command and their differences. So what we have is let's go, where is service enumeration? Here we are. So SV. And what this does, it probes open ports to determine services and service info. So if we were to just run, so in that last scan, we just ran a basic Nmap scan without service enumeration going on. And let's run this. Let's do a fast scan. That's what the -f does against our metasploitable system here. And in this output, we see we have a bunch of port numbers and possible services that are running on those ports. Now, Nmap doesn't actually know specifically what version or even if these are running FTP or SMTP. It really what Nmap is doing here, it's saying, hey, we got port 21, and by default, FTP runs on port 21. Right? Same thing with port 22. Most common service to run on port 22 is SSH. So really, this is just telling you, it's like, hey, you know, this is most likely running a version of SSH or FTP. When it could potentially be running, you know, HTTP or something completely different on a obscure port. So that's where the SV command comes in. This helps us identify specifically what is running on that system. And we will also get into the habit of using the -v, which is verbose. And really what verbose is, it just gives you additional output about your scan. It's optional. I like to have it, especially if you're debugging network ports and you want to see more specifics on how your scan's running. That's what the -v does. So we will run our scan here. And in our output, we will see much more information about the version numbers and what's running on those ports there, right? Like we have the version of FTP that's running. We have, you know, we could see it's our OpenSSH version. We could see that we have, you know, an Apache web server, right? So that is, and you know, the main reason you want to use that SV command is to see, you know, not just the version, but also if that version might be really outdated or old, and it could potentially be vulnerable to uh, an exploit, which, you know, for example, some of these definitely are. And also the SSH port, you know, we can see that it's running 4.7, which is old, so it might be using a much weaker encryption than what is today's standard. So that is where that SV command comes in. Now the A command is essentially the SV command but on steroids, because it's not just going to identify the port, the version of the port. It's going to start probing it and using Nmap's scripting engine to fire scripts against those ports to see what it can get into, like what the specifics of what's running on those applications. Like for example, you know, it might pull down the landing page or subdirectories on the Apache server. It might try to log into the FTP server. It might, you know, start testing and see if it can get to inboxes and stuff and identify the domain name on the SMTP service. So that's where the -A is. And this one is a lot more noisier. So if there is like endpoint detection software, chances are, you know, if they're decent or up to date, it might flag this. Some will, some might not. So you got to be mindful. But what that would look like, we'll run this, and this is going to take probably about 3 minutes to scan. So I'm going to run it, and I'll cut the video, and I will come back when it's done. Okay, so our Nmap scan completed with the -A flag, and let's scroll to the top here, and we'll go over what it did and what changes we have here. So when we use that -A flag, we're using the Nmap scripting environment, and Nmap's going to start running more aggressive scripts against these open ports to that not only identify the version of what's running on those ports, but also it's going to start interacting with the endpoint application to look for like common, you know, common things like, for example, if FTP, if you can log in anonymously, which we can see it says we can. It'll get us some additional application information. Same thing with the SMTP, which is a simple mail transport protocol. So this is a mail protocol. We can see that we have some information about our domain. It tried running some of these commands here, and it also checks if SSL is supported, which it says it does. And then down here on the HTTP port, we have some of our header, server header information, tells us about the version, as we can see here. We have the title of the endpoint web page and some of the supported methods that Nmap identified as compatible on that page. So this is the -A. And now for the scripts themselves. So these are actual scripts on the computer that you can go in and read, and you can find them in your filing system under your program files, wherever your Nmap installation was, Nmap application was installed to, and under scripts. And under here, for example, if we go down and find FTP, we can see right here, FTP anon. This was one that ran. And we can actually see the script that ran. And we could go in here and modify it. We can create new scripts if we'd like. It's written in Lua. All the NSE scripts are written in Lua. So it's a pretty simple language to learn if you have scripting background, or you're looking to get into scripting and play around with network protocols. This might be a good way to get your foot in on it, is just to go in here and play around. So that's where you can find the scripts. So when it finds an open port, it's going to try to find the scripts associated with that port, and it's going to run them. So, so that is the -A. And like I said, this is a very aggressive scan. So, if that server is running like endpoint detection software or firewall or anything like that, chances are it might get flagged, it might get reported, and that's why you want to do your reconnaissance thoroughly before you start going guns blazing with the aggressive stuff. So that is Nmap. One quick note before we end this video, I just want to specify to my viewers and whoever might be finding an enjoyment in these videos that I make these videos strictly for educational purposes. And I run these when I'm testing things, I'll run them on virtual machines or in a CTF, like try-hack-me, on systems that you have consent for. You never want to run these types of scans on just any system on the internet, because that you're drawing the line there. And so when you're using Nmap and you're following in my videos, ensure that you're doing it on a virtual machine that you own, or on a try-hack-me box, or if you're learning and you're just reviewing for like an actual pen test engagement, that you have consent to conduct reconnaissance or to perform a network assessment or vulnerability assessment on those systems that you're preparing for. So for today, that is everything I have. I hope this was informative, and I'll see you in the next one. Have a good day.